Hello and welcome to the characteristics of quadratic functions. Let's go ahead and begin. Before we talk about the characteristics of a quadratic function, let's refresh ourselves on what is a quadratic function. So, quadratic function is an equation containing a single variable of degree 2. Ax squared plus bx plus c equals 0 is the standard form of a quadratic function, and that's typically what we like to use here. Go ahead and highlight that. All right, the ax squared is considered the quadratic term because of that x squared. The bx is considered the linear term because the highest exponent on that x is a 1. And then this c is considered your constant term. That's the number just by itself. A, b, and c are all real numbers, but a cannot be equal to 0, or else it will not be a quadratic function. A is called your leading coefficient. It is the coefficient of the highest degree variable. Go ahead and pause the video to write that down if you have not written this down before. All right, some other vocabulary terms. Parabola. The graph of a quadratic function is a U-shaped curve called a parabola. So when you see me talk about a parabola, this is what I'm talking about. If a is greater than 0, that means a is positive. It opens up. Think of a smiley face. If a is less than 0, that means it's negative. Think of a sad face. It opens down. Again, pause this video so you can write that down if you've never written it down before. All right, now let's talk about some key characteristics. The vertex of a quadratic, of a parabola, also known as the maximum or minimum, is the highest or lowest point. So say I graph, that's a parabola. This would be the vertex, that's the minimum. Or I could do it this way, where it's upside down. And then this is your vertex. This would be considered the maximum. Both of these are considered the vertex. Okay? It is a turning point of the parabola. The axis of symmetry. So the axis of symmetry is a vertical line. The axis of symmetry is a vertical line that passes through the vertex and splits the parabola into two equal parts. So if I was to draw a vertical line, let's just pretend this is nice and straight. This line that we have that splits it into two equal parts is called your axis of symmetry. Okay. The y-intercept is a point where the graph crosses the y-axis. The x-intercept is a point where the graph crosses the x-axis. And a quadratic function can have two 1 or 0 x-intercepts, but will only have one y-intercept. Go ahead, pause the video and write that down. All right, welcome back. Here are some more key characteristics. The intervals of increase or decrease, those are the x values when the function is increasing or decreasing from left to right. Intervals were positive or negative, those are the x values for when the function is above the x-axis, that's what we call positive, or below the x-axis, that's when it's negative. A function is positive when the graph is above the x-axis, so when y is greater than 0. It is negative when the graph is below the x-axis, when y is less than 0. And then the end behavior is the function's behavior as the x values increase to positive infinity or decrease to negative infinity. Finally, the average rate of change. The average rate of change calculates the slope between 2 points. A quadratic function has a variable average rate of change, but you can still calculate it, and we do that using the slope formula. M equals y2 minus y1 all over x2 minus x1. Again, if you've never written down these characteristics, please take a moment to write them down now. All right, so let's go ahead and fill this in. It says identify the characteristics of a function. So go ahead and if you want to pause this video and fill it in, let's see what you know already. Okay, so let's take a look at this green dot right here and try to guess before I say it. That is called your vertex. That's the highest or the lowest point of a parabola. So this is called the vertex. All right, I see this right here. It's intersecting the y-axis. So this is called your y-intercept. And if I was to actually give it a label, the y-intercept is at 0, 8 here. This is another y-intercept. It's intersecting the y-axis, and the coordinates of this y-intercept is 0, -5. Let's go ahead and put the coordinates of the vertex while we're at it. The vertex here, this is -1, 9. So the vertex here is -1, 9. The vertex here, this is 2, this is 2, -9. That's what this vertex is. Start from the center to -9. All right, here I see where it crosses the x-axis. These are called your x-intercepts. Let's go ahead and label those as well. This is -4, 0. And this one over here is +4, 0. Again, we see our x-intercepts here as well. Let me see if you can finish labeling them before I do. This x-intercept, okay, this is 0. This is -1. So that's -1, 0. And this is 0, 1, 2, 3, 4, 5. That is 5, 0. And then finally, you have this vertical line that splits it in half. That's called your axis of symmetry. Let's use a different color here. Maybe a lighter blue. So this is the axis of symmetry. And the axis of symmetry is actually the equation x equals whatever that x value is. And the x value is -1. Again, here's your axis of symmetry. And in this case, it would be, this is the x value, x equals 2. And these are your key characteristics of a quadratic function. Go ahead and pause the video and write that down. All right, now let's bring it all together. Here is a function. It says f of x equals x squared minus 6x plus 5. The graph of the function is shown below. So here is the graph shown below. Okay, it says find its vertex. Is it a maximum or minimum? So let's go ahead and find the vertex. So the vertex is the highest or lowest point in the graph, and I see it's happening right here. This is 0, this is 1, 2, 3, and then I'm going to go 1, 2, 3, 4, -4. So my vertex is at 3, -4. It is a minimum because it's the lowest point. Minimum. The domain or range. So the domain of a quadratic function is all real numbers. It's always true for your x values. So for your domain, it's going to be always all real numbers. Now the tricky part though here is going to be our range. Our range tells us, we're looking at the graph from the bottom to the top. So our range starts or ends wherever your vertex is. So in this case, our range starts from the bottom. It starts at -4. So y is greater than or equal to -4. Or you could say -4, infinity. Because it starts here, it is equal to, and then it keeps going, and it never ends. Okay? Now, if this was upside down, I would say it goes from -infinity, and then it would stop wherever that maximum is. So it just depends on how you're looking at the graph. In this case, our vertex tells us where our range is going to start. So it starts at -4 and it keeps going. All right, find your x and y intercept, your x-intercepts and your y-intercepts. All right, well, my x-intercepts I can see very clearly here. So that's going to be 1. So I'm going to do my x-intercepts first. It's going to be 1, 0, and That's 5, comma 0. Okay, now the y-intercept, we're going to have to graph it ourselves. Like if the graph gets cut off, you can graph it yourself. Y-intercept. Or you could plug in 0. I'm going to plug in 0 for x. 0 squared minus 6 times 0 plus 5. That means f of 0 is going to be equal to 5. I can look here and I could see that. So it's going to be 0, comma 5 is my y-intercept. So you can either graph it and see where it intersects it, or just say x is equal to 0 and do that. So they gave us the function up here, so even if the graph is cut off, you could still graph it and figure it out. State the decreasing and increasing intervals. Okay, so I'm going to erase all these other marks so that you don't get confused as we're looking at the graph. Okay? Decreasing. When something is increasing or decreasing, we're looking at the graph from left to right. Okay? So if I look at this graph from left to right, here it is. The function is actually going down. From left to right, it's going down, and then it stops. And this is when it stops. This is the x value for when it stops. So it's decreasing. It starts decreasing from negative infinity because it's always decreasing from that end. So this is negative infinity. It's decreasing. It's decreasing from forever and ever. So it's decreasing from negative infinity, but then it stops decreasing when it comes to the vertex. And the vertex is at 3, the x value. That's when it stops decreasing. Then it shifts gears and it starts increasing. So then it's increasing. The function is increasing from 3 to positive infinity because it keeps going up. Okay, so those are the intervals when it's decreasing and increasing. All right, the next question says state the positive and negative intervals. So that means they want to know, when is this graph above the x-axis? When is it below the x-axis? So this is when my intercepts come in handy. Okay, it's positive here. It's above the x-axis, it's positive. Here it's above the x-axis, so it's positive. Here it's when it's below the x-axis, so it's negative. But I just want the y values. I mean, not the y values. I just want the x values. So it is positive. Let's see. And again, because I'm looking at the x values, this is negative infinity. This is positive infinity. But it's positive from negative infinity until it gets to the first x-intercept, which is at 1. And then it's positive again when it gets to the next x-intercept, which is at 5. And then it keeps going to positive infinity. It's positive again. And then it's negative only for this short little time. It's negative from 1, that x-intercept from 1 to 5. That's when it's below the x-axis. So those are the x values from when it's negative. The end behavior tells you what's happening in the function. And because it's quadratic, the end behavior is going to be the same on the left and on the right. So as x approaches negative infinity, that means we're looking at the left, right? So you could just say on the left-hand side, y is approaching positive infinity. And as x approaches positive infinity, that's on the right-hand side, our y is also approaching positive infinity. It's also going up. So our end behavior is going to be the same. If it's either going to negative infinity or positive infinity, both sides, the left and the right, are going to match. Both the left and the right are going to match. Then finally, well, not finally, it says give the equation for the axis of symmetry. That's the line that cuts it in half. The equation is going to be x equals, and it would cut it in half at the vertex. The x value of the vertex is 3. So x equals 3 is the equation for the axis of symmetry. All right, we're almost there. One more characteristic for this graph. Whew, a lot of writing here. And remember, you can always, the cool thing about this is it's recorded, so you can always go back and rewind. All right, the last part says, what is the average rate of change over the interval 1 to 3? So from 1, they're giving us the x values. This is when x is 1, and this is when x is 3. Okay, so what's the y value? So this is 1 comma 0, and this is 3 comma negative 4. They want the average rate of change. So that means I'm going to use my slope formula, y2 minus y1 all over x2 minus x1. I can still use it even though it's not going to be the same if I chose different intervals, but I could still use it. This is x1, y1. This is x2, y2. So I'm going to say negative 4 minus 0, because that's y1, all over x2, which is 3, minus x1, which is 1. Negative 4 minus 0 is just negative 4. 3 minus 1 is 2. Negative 4 divided by 2 is negative 2. So my average rate of change over the interval from 1 to 3, m is equal to negative 2. And again, if I change my interval, the answer will change. You can still calculate the slope of a quadratic function. It's just going to change depending on how you change your x values. And this interval tells me the x values. Whew. That was a lot of work. Pause the video, rewind it, go back to certain parts if you need to understand all the characteristics of a quadratic function. But these are the key characteristics of a quadratic function in a nutshell. I hope that made sense. Let me know if you have any questions.